Okay, and now the last bit for this week, a little topology. We need to think about describing parts of the plane because we want to think about functions as mapping, the domain is the plane, the range is the plane. What do we want to talk about these things? So B of Z0 comma epsilon is called the neighborhood of Z0. Excuse me. Think of this as being a circle. B actually stands for ball. Center is 1. Radius is 1/4, right? So my center is Z0. My radius is whatever epsilon happens to be. So what is B 1 comma 1/4 is the point 1. Here's the circle of radius 1/4. And the ball is the stuff inside the circle. It's everything that's within that radius. It does not include the circle itself. Okay, so that's what that notation is. It gives you a center, it gives you a radius, and you just draw that and you include everything that's inside the center. A deleted neighborhood is just the same thing, but you take the center of the circle out, right? 0 is less than, the distance is less than epsilon. There isn't any particular notation for this like there is for a ball of radius, of center 1 with radius 1/4. So if S is a set somewhere in the complex plane, an interior point means that there's some neighborhood contained entirely within S. A point is an exterior point if there's a neighborhood of Z that is disjoint from S, that doesn't meet S at all, and point Z is a boundary point. Every neighborhood contains both some points in S and some points not in S. So here's a set. What does it look like? This part, make sure my pen works. This part, modulus of Z less than 1, that means we want points that are at most 1 unit away from the origin. So if we think about the complex plane, S, I'll put a little dotted circle of radius 1. S includes everything inside that circle. Real Z, remember that real Z is the X, everything that's greater than or equal to 0. So that means we want numbers on this line and all the way through there, because that's where X equals 0. And then we want everything out to the right. Great, so that's what the picture is. It's everything out to in the right half plane plus this little part of the left half plane. So what is an interior point? An interior point is any point like this here, where I can draw a little circle around it and never leave the set, right? So if I pick any X, like here, that's not on the y-axis, I can draw a little circle that never actually gets to the y-axis. Same thing here, if I take a point here that's not on the boundary of this circle, I can draw a little circle around it, a little neighborhood that's entirely within that circle. What are exterior points? Exterior points is this neighborhood of Z that is disjoint from S, right? So if I take this point here, that's outside of S, and I can draw a little circle around it, that's completely outside of S. This circle doesn't meet the set at all, right? And this circle, that point, this point. So the exterior points are all these points over here that don't run into this. The interior points are all these ones here. What are the boundary points? Well, there's certain points here that's on this line, and if I draw the circle around it, it's going to include some points that are not in S and some points that are in S. And it doesn't matter how small I make the circle, that's always going to happen. So these points are boundary points, right? Because there's some points not in S and some points in S that are really close to it. These points here are also boundary points, right? If I take this point, there's some points inside the circle that are on it and some points that are outside. So that's also a boundary point. This here is not a boundary point. It's on this boundary of the circle, but I can draw a little circle around it that's entirely within the right half of the plane, so that's not actually a boundary point. So the exterior points are the points out here, the boundary points are the points here, and the interior points is everything over there. Keep in mind that a boundary point can either be in the set, so these boundary points are actually in the set S, or boundary points don't have to be in the set S. These boundary points here are not actually in the set S because this is less than 1. Okay, so a set is open means that all points are interior points. A set is closed means the complement of the set is open. So a good rule of thumb is open sets do not contain any of their boundary points. Closed sets contain all of their boundary points. This was neither. Some boundary points are in the set. Some boundary points are not in the set. Right, so exterior, interior boundary all depends on drawing little circles around your point. Open means every point you can put a little circle around it. A set is closed means if you look at the complement, every that's open, every point can be surrounded by a circle that's outside of the set. So weirdly, there are two sets that are both open and closed. So a C with a bar down the middle like that, that means the complex plane or all complex numbers. That's definitely open. What's the complement of C? What's all I can't spell today, complement. All points that are not in C, well, that's just the empty set. So the complement of the implicit set is open, so that means empty set is a closed set, which is a little weird to think about, right? But that's how the definition works. There's no boundaries for either of these sets. So what makes something an open set? So an open set is that if this statement is true, right, then you get a open set. But keep in mind that this is an implication, it's an arrow, right? P implies Q. Z is an element S means this happens. So if P is false, P implies Q is true. Is this ever true? Well, no, there's no P that's in the empty set. So if S equals empty set, so this is all true. The implication is true. So phi is open. And the complement of phi is the complex plane. And the complement of an open set is closed, right? Does the complex plane include all of its boundary points? Well, it doesn't have a boundary, so the question's a little off. So the complex plane and the empty set are both open and closed, but those are the only ones that we will run into in this course.